Okay, so here are the notes for 1-4. We're talking about logarithmic functions. Also, the short, you just say log, so log functions. And we're still talking about inverses. Okay, so it's telling you there gives you an equation, and the inverse of the exponential function, f of x equals b to the x power, that's exponential function, is the logarithmic function log b x. Okay, so when you're given it in this form, the inverse is this. When you're given it in this, the inverse is this. Okay, so it goes either way, but they're inverses of each other. So when it says, what is the inverse of f of x equals 2 to the x, you can tell that this is similar to the b of x, right? Where b is equal to 2. So if we want to write its inverse, we're going to write the log. So f of negative 1 of x is going to be equal to log 2. It's a small 2, like a subscript of 2 with an x. That's how you write it. So when you're given this as the function, the inverse is this. That's what we just said. So now look, graph f of x equals 2 to the x power and its inverse on this graph. Okay, so we're going to, in our calculator, we're going to type in your calculator y equals 2 to the x power. Okay, so over here I'm going to go to y equals, and I'm going to type in 2, and then the house top, and then an x. Okay, and graph. Okay, so it's going to look like that. And now then I'm going to go to second graph, which is my table, and I'm going to get my points, my x and y points from here, and I'm going to fill them in the chart on my paper. Okay, so you're going to get negative 2, 0.25, negative 1 is 0.5, 0 is 1, 1 is 2, 2 is 4, and 3 is 8. Okay, so now for our inverse, what are we going to do? Just like we learned last week, we're going to switch our x and y's. So what our y's are over here is going to become our x. So 0.25, 0.5, 1, 2, 4, and 8. And now our y's are going to be our x's. So negative 2, negative 1, 0, 1, 2, and 3. We just flipped them. And now you're going to plot your points. Okay? So I'm taking my first graph over here, negative 2 and 0.25. So negative 2 and then 0.25, which is going to be like right here. Just get it as close as you can. And then negative 1 and 0.5. So negative 1 and 0.5, which will be in the middle. And now we have 0, 1. We have 1, 2. We have 2, 4. And we have 3, 8. Okay, so when you're graphing that, it's going to look kind of like this. Okay, and I'm going to label it. That's my f of x. That was this column where it says f of x, which is 2 to the square root of x. Okay. Now then my inverse, I'm going to graph this one. So 0.25 is my x, and negative 2 is my y. 0.5 and negative 1, 1 and 0, 2 and 1, 4 and 2, and 8 and 3. So we're going to get something that looks like this. Oops. Okay. So now if you were to draw your dotted line, just like we were doing last week to check, you can tell that they are a reflection of each other. They are inverses, right? So this is f of negative 1. Oops, f of negative 1 of x. Ran out of room there. So label it. I'll label what's f of x and what's your inverse because it's going to ask you questions about each one and you need to know which graph you're looking at. So now back over here it's saying what's the domain and the range for f of x. Okay? And then we're going to have to put the domain and the range for the inverse. So now domain and range, domain is your x values and range is your y. So you need to look at what's happening to the domain on your function f of x. So on this line right here, your x and your y, you're looking at your x's for domain. So what's happening? It's going to keep going up and to the right to infinity, and it's going to keep going down and to the left to infinity. So that means it's going to infinity to the left and infinity to the right, makes your domain all real numbers. Okay, now your range is your y. So we're still looking at the f of x. So your y is going to be going up to infinity, but when it's going down, it's always going to just get closer and closer to 0, but it never crosses 0. So your y is going to be greater than 0. So it's never reaching 0 or going below 0. Now then, it's asking for the domain and the range on the inverse now. So looking at your x here, your domain, it's getting close to 0, but it's never crossing. So that means your domain would be x is greater than 0. And your range now is up and down, your y. So what is happening here? It's continuing to go up, and it's continuing to go down to infinity. So it would be all real numbers. Okay, I'm going to give you a big view of that one so you can see it. Okay, second example, you start with log 3 of x, and now you need to find the inverse. So using the formula up here, they give it to you in this format. So to find the inverse, you need to put it in this format. So your b is 3, so you would have 3 to the x power. And now we're going to graph this first. You're always going to graph your exponential form, which is your number to the x power. Okay, we can't graph logs. So we're going to graph this one, and once we fill in our table, we're going to flip our x and y over here. So you're going to go back to your y equals and clear it out. And I'm going to put 3 to the x graph. And now I'm going to go to my table, and I'm going to put my points that I get into my chart over here. So -2, -1, 0, 1, and 2. 0.11, 0.33, 1, 3, and 9. And now I'm going to flip them over here. So I'm going to put my x's as my y's. -2, -1, 0, 1, and 2. And then 0.11, 0.33, 1, 3, and 9. Now you're going to plot your points. So you're going to get -2. I'm graphing this one first, my inverse. So we'll do -2 and 0.11, which is just barely above it. -1 and 0.33, 0 and 1, 1 and 3, and now 2 and 9. So it's going to look something like this. And that's my f of -1 of x. Remember, this is my inverse over here. So I labeled it my inverse. Now I'm going to do this one. Okay, so now I'm going to flip it. So I'm going to do 0.11. I'm going to get closer so you can see what I'm graphing here. So now I'm switching it. So my x is 0.11 and -2. Just real close right there. And then 0.33 and -1, which will be right here. And then 1 and 0, and 3 and 1, and 9 and 2. So it's going to look like this. Oops. Okay, so when you draw that dotted line down the middle, just to check and make sure they look like they're reciprocals of each other. I mean, they're inverses of each other. This is my f of x. Label it. So now I'm trying to find my domain and range of my f of x and then of my inverse. Okay, so let's do f of x first. So our f of x was this one. Domain is your x. So what's happening on the x for this one? It's continuing to go to the right to infinity. this way. But when you're going left, it's not ever crossing 0. It's just getting closer to 0. So your domain for this one is going to be x has to be greater than 0. But on your y, which is your y-axis, okay, that's our range. It's going to keep going up and to the right and up to infinity, and it's going to keep going down to infinity. So that means your range is going to be all real numbers. Now then, looking at our inverse, if you look at your x's, it's going to keep going up and to the right to infinity, and it's going to keep going to the left to infinity. So your domain is going to be all real numbers. But your range is your y, which is meaning up and down. So what's happening? It's going up to infinity, but it's not going down to infinity. It is going down, and it's going to keep getting closer to 0, but it never touches 0 or crosses 0. So therefore, our y is greater than 0. Okay. So you can tell in both of these, usually you're going to get all real numbers flip-flopped. Okay, and your range and domain, depending on the inverse. With the inverse, okay? So it's just going to depend. You'll get one or the other for each one of them. Okay, so there's 2 examples. The 3 and 4 in the notes work out the same way. It's the same process.